Hey, how are we doing? Hopefully I don't have the computer going here. 2 seconds. There we go. So we have everything up and we are streaming. How is everyone doing? I see some questions about, can you go over questions 2 and 3? I think that's on. Awesome. Thank you, everybody. Mohammed, you are awesome. Leia, you are awesome. Let's do this right here. We got questions on 2 and 3. See you at 250. Yes. More 320. Thank you so much. Hopping in, asking questions right there. Let's take a look at this right here. Let's see. Mohammed, you still there? We're going to work on some of the assignment right here. Let's take a look. Question 2 and 3. So we'll put this in the video right here. You asked. We are going to do it. This is 320, I believe. So I've got too many files open. Oh, wait. Right here. Look at this. We got it. Okay, cool. Okay, questions 2 and 3. You bet. Questions 2. Wrong question 2 right now. Is this question 2? Uh-oh. Okay, so you need to enter in your student ID. So we're going to enter in our student ID right here. We're just going to go ahead and enter that in. And we enter in our student ID. And we print the student ID. And we have it right here. So with this right here, we can print out the student ID. We can have this. And we're going to then enter in these questions. How many bars would a histogram have if its first bar left edge was at 15, the left bar's right edge was at 75, and each bar was 0.5 wide? Hint, the number of bars is one fewer than the number of elements in the sequence you need to generate. So this is one fewer than the sequence you need to generate. So let's look at this right here. What is this sequence we're going to generate right here? Let's look. 15 is the start, 75 is the end, 0.5 is the width of it. And we can kind of view this on the background right here. Let's make a histogram of it. So we can go here to hist, and we can enter in something like hist of 0 to 100. So here's a histogram going from 0 to 100, and look at this. The number line on the bottom, now it might be confusing. This is a 201 question now. What are the bin widths? The bin widths here are 10. So that's a 201 review. If 201's watching right now, feel free to drop questions in here. But the bin widths here are 10. So we see here 0 to 10, 10 to 20, 20 to 30. The bin widths are 10. But what is this number line sequence? Maybe if we make it, we'll show more numbers? No, show more numbers. I want to show all the numbers on the number line. It'll never do it. It'll never display all those numbers. We could make it show less numbers. Look at now it'll display less numbers. But with this right here, what is this sequence of numbers we're viewing right here? The sequence of numbers is what? And now it's even crazier, but think about right here, 0, 20, and we'll do that one next here. You got it, Ting Yang. So we have here starts at 0, goes to 100 by 10. I know it goes 10, 0, 20, 40, 60, 80, 100, but it goes 0, 10. There's a line right here, 20, 30, 40, and great questions in the chat. So what is going on right here? What should we do? This is just an example. Let's see right here. How do we make this sequence? Who knows how to make this sequence? Oh, did I get 770? I think the answer is 999. I think you're right, Ting Yin. It might be 999. I think you're right. Because is it the largest area code? If it's for E, I'm pretty sure the largest area code is 999. Not to say what the answer is, but I'm pretty sure the largest area code is 999. And yeah, I think you got it right. Not saying what the answer is, but kind of saying what the answer is. That sounds right, because I'm like, wait, 999, that's the largest area code. What is this sequence right here going to be going from 0 to 100 by 10? What is the sequence going to be going from 0 to 100 by 10? So I'm kind of saying it. We need to make a sequence from equals 0 to equals 100. Yes, I think we're seeing in the chat. Yeah, and here I'm going to show the two ways right here because it's important we can see the differences. Great job. 100 points if you're here during office hours asking questions. That's what we want to see. And we have right here. Great job. And so you've entered it in with the defaults, which is fine. I mean, like, I'm not being like, it's fine. It's completely fine to enter it in with the defaults. I do this a lot of times. You'll see me code this way. It's the same sequence, but if you want to use things out of order, or if you want like a length, you can use length or length out. A length of 1 only gets you one object in the sequence. So the last argument is by default, but you could ask for 500 elements. And there's a sequence of 0 to 100 with 500 elements in it. So the length or length out, in the documentation it says length out, but it does the same thing. And I read one time why it did, and I was like, oh, that's interesting. And then I was like, okay, it's the same thing. I think it does a partial match is what it is. It does a partial match, and it knows that you're trying to do length out, which is the actual argument, but it works. We're not going to use that right here. We're going to take a look at this sequence. And you say, well, Brian, there's 10 numbers. No, there's not. To figure out how many numbers there are, to figure out how long this sequence is, what is an argument I can run or a function I can run on this right here to figure out how long this sequence is. Now, I could count it. I could go, oh, I'm disappearing, so I can't count it. I got to run code to count it. What could I run on that to count it to see how long it is? Boom, length right there. Great job, Mohammed. We're going to do length on the outside of this. And it's 11 long, which, as the question says, the answer to this is 1 minus. So if you're looking over here, there is 1, 2, 3, 4. I can't do that. 4. It's the count. 5, 6, 7, 8, 9, 10. Wow. Amazing. Amazing. There are 10 elements right there. There are 10 elements or 10 bars. 10 bars right there. And so we see 10 is the answer. So guess what? We have confirmed the answer with another example. Let's go to our question right here we generated. What was our question again? I have to see our question again. Our question is going from 15 to 75 with 0.5. So 15, 75, 0.5, and boom. There we go. We've done it. So that is the answer. And the reason I did this example right here is we could actually see it. It helps a lot of times to see what we're doing. Like if we have something that starts at a spot and goes to a spot and goes in sequences of 10, because that's what we made originally, is a histogram that starts at 0, goes to 100, and has bin widths of 10. Viewing that visually helps us kind of see, okay, there's 10 bars there. That's why we're subtracting 1, because the sequence was too long. If you look at the 11 sequence, this is the number sequence, but we have to subtract 1 from it. And you might ask, why is that? Well, it's because we actually are making, the bars actually end at 10 through 100. So technically, you could just make a sequence that starts at, the next number up. The first bar ends at 10, then 20, then 30, then 40, and all the way to 100. So you don't count the 0. That's why we do the 1 minus. You say, well, why are we doing 1 minus? Because we don't count where the first bar starts. Hopefully that makes sense to everybody right here. But we can just see how many bars will be in this histogram. Kind of a good question to see. We can analyze stuff very quickly using code. And what's my second question with my random student ID number? Do not put in yours. We just type random ones up there. And put in yours. But we need to now. Awesome. Great job, Mohammed. Hopefully this is helping out a lot right here. What's the 606th element of a sequence that starts at 3.2 and increments by 0.3? Okay, so that's going to be the by. Oh, you can't see it from my head. Boop. Let's raise this up so you can see it. We have to raise this up right here. So what's the 606th element? Now, I want you to type it in the chat or be thinking, what should we do when we have... See, now I should make myself... Oh, I've got food. I got lunch. That's why I was 3 minutes late. Oh, you can't see it's off screen. It's lunch. I got to remember to eat. It's important. So I might disappear from home and turn off the mic, and I'll come back and be like, ready to go again. So how do we get element positions? How do we get element positions? How do we get... What's this right here? How do we get element positions? You want to break this down to parts. How do we get element positions? What do we do to get element positions? I don't know. I don't know these things. I never know how to code. Boom, square brackets. That's what I was talking about right here with those square brackets. Square brackets are right above your quotes and all that good stuff. Yes, I do that too because it looks like you're making a square, but hey, they're square brackets, so they make a square. So let's go down here, and we want the 606th element of a sequence. So the sequence we wanted, we got to go back to the code. It is going from, starts at 3.2 and increments by 3. So the issue is, you might say, oh, Brian, if you're making this sequence that starts at 3.2, let's go from equals 3.2, and then we need to go, that it's going to go to, and let's just put a big number here, 1,000, that's a big number. You say, well, why are you putting 1,000? I'll know it goes far enough out now. So this is a sequence that goes to 1,000. We didn't even need to go that high because we only need the 606th element, right? Well, this is more than enough. So you could go back here if you wanted, but we don't have to. It's a rather large sequence, but let's just find out the 606th element of it by connecting this to the end of it. So what this does is it prints out that element. Try doing some different stuff right here to practice, like doing 1 through 5. And what will this do? Well, I said it, 1 through 5. This prints the elements 1 through 5. So the first through the 5th element are printed to the screen. We have other ways of getting the first elements, though, like head. This will get us the first 6 elements right here by default. Or we can go tail, and these are kind of a review. Now we have a quote. Mubot knows this quote. I think it's quote number 7. Mubot, tell us what's going on right here, Mubot. Mubot has a new quote it learned today. It learned 2 new quotes today. Do not write everything Brian does when doing an assignment. Do what Brian says, not what Brian does. Brian is usually right, but sometimes too right. So Mubot knows what is going on. We have this right here. Don't write down everything I write down. Write down parts of my code, because just to make it clear, the correct answer to this version of the problem I'm working on right here is going to be that right there. That's going to be the correct answer. But just so we can see other examples and understand what's going on right here, we have here the sequence of the numbers 1 through 5, or the sequence of the numbers getting the first through 5th element, and then the head function gets the first 6 by default. You could ask for the first 2. That's an additional argument, and you could ask for the last 2. Now, I want to make it even clearer what's going on right here, because a lot of people are brand new to coding. This sequence is just going to be called X. Once again, let me delete this code after I'm done. But if you're confused by everything inside of there, just realize that the sequence is X. Does that make sense, Mohammed? Does that, like, okay, that sequence, that's X. So what am I taking? The first 2 elements of the sequence. Boom. What am I taking? The last 2 elements. I can change this to the first 10 elements. I can change this to the last 10 elements. So you can choose, and this is advanced. This is not advanced, but this is something outside of the original question we're working on here, just so we can see how we can go to certain positions. You could even go to the first 10 elements and take the 5th element. So that's the first 10 elements taking the 5th. And this is how we take positions right here. So that's got it. Don't do all this additional stuff. Let's kind of show the version that we need. And let me look. I'm going to do C, and then I'm going to look to see if there's additional questions. Put some timestamps in the videos if you want. Definitely helps out so people can come back and review. So with this right here, let's see the last question I had. Consider a sequence. I'll raise it up again so everyone can see. Consider a sequence that starts at -2 and ends at 12, which has 321 elements. How many elements are greater than 6? Don't do this all at once. So when you hear consider a sequence and you hear starts at, what argument in sequence when you hear it starts at this? I'll answer the next one, but when you hear it starts at this, what argument is that in a sequence? It's like sequence, and then an argument's going to say something this. So it starts at this. I didn't say the word yet. Starts. You're close, Mohammed. So think about this. We need to build the sequence first. Let's build the sequence. So let's do sequence, and then let's go from a number. Well, I just said it. So we're gonna build let's build the sequence first. And that what you have looks yep. And what you have looks close to right. Like it might, if I saw the whole thing, you might have it right. So I need to bring the code. Ah, there it is right there. Okay. So let's go a sequence from equals, and the from is going to be -2. And then we're going to go here. It ends at this. So you can see it by my head right there. It ends at 12 right there. So since it ends at 12, we're going to go to 12. And this is where people get confused. There's an additional argument, the length or the length out we talked about earlier. The length controls how many elements there are to the sequence. So imagine you had, a sequence going from 0 to 100, and it had 11 elements. You'd see that right there. I'll show that in a moment right here. But we need to do the 321 elements, and then we'll do the rest of this in a moment. And we need to do length, because that'll do by default. If we don't enter in length here, it'll use the default of by. So that's a sequence we can confirm with 319, 320, 321 elements. It ends at 12, which we wanted, and it starts at -2. Your questions are probably a little bit different than mine, but we can confirm starts at -2 and goes all the way up to 12. Now what I'm going to do is I'm just going to call this X again. This will overwrite X in my environment. It's all right if you do that. Just make sure if you go back up, you rerun code. You could call it Y if you want, or you could call it X2. Good movie there, X2. Man, I saw X-Men 1 in theaters and X-Men 2 in theaters. Good movies. Like, I wasn't even born yet. And I'm like, it's going to get less funny the older I get. Anyways, so we're looking here at the vector X, and we want to find the things that are, I think, greater than 6. I gotta know what that question says. Is it greater than 6? It's greater than 6. Greater than or equal to? No, just greater than 6. So now that we have the vector x2, and Muhammad basically had it, we're just doing greater than 6. Now, what is this going to return? What is this going to return? 2 seconds here. Brian's going to disappear. You got to tell me what this is going to return. Boop. Muhammad, you're right. I'm back. I was not eating. So it's a horrible idea. I'm going to have like food on my lips or something. So it's going to return trues and falses. True, false. Did I not run that code? No, I've ran that code. So it's going to return trues and falses right here. And so with the trues and the falses, we want to know how many elements are greater than this. So we want to know how many elements are greater than this. What are we just going to put this inside of? You're the best, Muhammad. I miss you guys. I miss you guys. I miss seeing you guys. I miss seeing you around the fort. I run into Muhammad around the fort. You got it. You got it. You guys are the best, and I love the positivity. Like, you know, like I remember all the way from Sat to 1, just like a year and a half ago now, right? Yeah, because you're in Michael's Cosmolica stuff. I miss seeing people around campus. When the world gets back to normal, I'll come back to campus more, and they'll be like, "Hey, that's Brian. That's Brian. I know Brian. That's that dude." Like, hey, what's up? I'm like, hey, what's up? That'll be. I don't know, but yeah. Which were you wondering about 3 also? Were you wondering about 3? I think if you were like, how do we do number 3? So that's got number 2 that explains it. I do want to say this. Let me expand upon what we did with the summing of it. When R has trues and falses, which trues and falses are seen as 1s and 0s inside of R. So the trues and the falses, if you do true plus true plus true plus false, what's this going to solve to? Question 3, you got it. Good. What is this going to solve to? Because this is, I think Muhammad made the joke in class. He did this. It should, yep, 3 trues. And then, so this is 3 right there. Because it's, trues and falses are 1s and 0s. So you could go right here. Ooh, here's a hard question. I'm doing tricky stuff right here. We should put this on the test. What will this solve to right here? It's not going to solve it. I think it solves to 3, actually. Yeah, I wanted to do this. This is what I wanted to do. This was my intent with that. It does solve to 3, and it's it doesn't take the mean of a vector. It takes the mean of true plus true plus true, and I wouldn't use it that way. And I'll explain why we would do something like this in a moment here. So and I'm going to go to question 3 next. This right here will return 1 because it's going to get us the percent of trues. So this is going to tell us the percent of trues in that vector, and so it gets us 1, where now there's only 66% trues, and now there is 33% trues. I don't know how to do thirds, and now there is 0% trues. So if you take a logical vector right here, and to make it a little more clear, let's just call it logical, if we knew how to spell logical. And we're going to store into logical. Once again, don't write all these things down. I'm just doing additional things. The logical vector right there has 0% trues. The logical vector right here has 33% trues. The logical vector here has 66% trues. The logical vector here has 100% trues. The same thing works for sum. You can do sum and say there are 3 trues in that vector. You could go sum here, and there would be 5 trues in that vector. And you could go false, and you'd get 4 trues in that vector. You can go mean, and we'll get 80% because there's 80% trues. Does that make sense how it actually views these as 1s and 0s? So it's just like if the vector literally right now was 1, 1, 0, 1, 1, you'd get the same result doing the mean of the vector. So R sees trues and falses as 1s and 0s in the background. It's like, oh, that's a 1, that's a 0. So you can do a lot of things with this. Like if you wanted to go to, once again, this is another example, then we'll do example 3 or question 3. If you load up library reg class, which I'll tell you installed if you don't have it, and you go to survey 10 and you wanted to see how many people are males, there's easier ways of doing this with a table. But you could go here to survey 10, $ gender equals male, and you could find out how many males there are. Of course, another way of doing it, probably easier, would be to go here and make a table of the thing, and there you go. You could find out the percent, and to find out the percent, the code would just be to go here and do mean. And I see additional question. I got you, Mohammed. Or you could do n row right here of survey 10. So both of these are going to give the same answer. That one gives that, and this last thing we'll do, we'll just make it so it only says the male amount. We'll go to the second element. So that's the second element of that table. So slow it down if you want, do a little bit of advanced stuff. I have one question. Why are we studying R instead of Python or SQL or C++? Really good question, Mohammed. Mohammed, that's another 100 points today. I love those. Like, why are we doing this question? Ask those questions. I would hate for students not to. Big reason is I code in R. I mean, it's like the biggest reason. A lot of data scientists, a lot of, I'll show the page here. Let me turn off my screen in the background. Let me turn off the screen. Whoop, that's the screen. There we go. My screen's gone. Give me a half second here and I'll explain. They'll do question 3. Let's see right here. What is his name? What is his name? I can't think of the gentleman's name. There, Bob Munchin. UTK. And there he is right there. Where's his data science page? So I'm going to show you a little bit about why we use it. And it's really good. R for stats. There it is. So let me pull this up in the background right here. 2 seconds. He's got ads. Articles. Here we go. Cool. Here it is. Let me go back to the slides. Slides right here. His site is R for stats. So, I mean, always be, no, we don't need your ad. So he went through and he did analysis of like where people are learning their skills. And so you see here Python and SQL. So Mohammed, when you said this, I've met Bob Munchin. He's a great guy. It's so funny when I met him. I was like, "Oh, it's so good to meet you." You know, and I didn't introduce myself. I did, so he was like, "Wait, and who are you again?" I was like, "Oh, I'm Brian." And when he's like, "What do you do?" I was like, "Oh, I teach statistics." I'm sorry. He's a really nice guy though, and he's really smart, and he does a lot of coding. So you see right here, the scale of this figure right here has there are 250 different jobs in it. So so wait here. R is also freely compared to SAS, which has only 8,123 comparisons to R is this. So this is Python is the lead with this many jobs. SQL is the lead with this. So this is, he collected data from February 2017 to May 2019. He goes over the data collection, goes over all this stuff right here, and talks about what's being used. And you see R right here, and it's above SAS. R is up there with, Amazon, Java, SQL, and Python. But he goes into specifics right here on what people are using in different industries. And so you look at all this right here, and he's got the pros and the cons. And here I think is in social sciences maybe. So you see SPSS, very kind of popular among a lot of social scientists. R, SAS, or might it be in technical research. Scholarly articles. So this is in scholarly articles. You see this right here. Python's not as used as much as scholarly articles. Which section is this right here? Rapid Miner. It's so interesting to go through and see everything that we have so many ads. Here's the popularity of certain softwares. We're seeing R increasing. SPSS is on a rapid decline. So you're looking at like publications and stuff. SAS has also been declining. Where's Python? I don't know why Python's not on here. I guess because it made scholarly articles. But if you want, check this out. This is a really great site that goes over everything. And to me, I think it's very unbiased research. He goes over the popularity. And one thing to say is R is very popular. There's so many ads. And here's R right here. This is, I think, serves how people are using it, their primary tools, other use. And so you can see the different usages and utilizations in different industries. So this is really great here. There are Python and R SQL classes at UTK. You could go to the MSBA route and take even more classes about Python. So yes, exactly. Python and SQL, look at this right here. Python and SQL are right at it. Really, Python and I wouldn't learn Python and R. If I could only pick two, I'd pick like Python and SQL or R and SQL. SQL, is database management. So I'd either pick like Python and SQL or R and SQL. So SQL's great, like and Python's great too. And then I'd pick maybe like Tableau for visualization, even though I like Shiny and stuff like that. But I think he updated this site. What service analytics tool are you currently using? So I guess R is more analytical, and there's Python on here, but he looks through all like the literature and everything. Needless to say, here's the whole point of this. Python is very good. Python's very popular. Python and R kind of fight each other out, and there's not a wrong one to use. And so it comes down to a little bit of preference. And what I meant by like I learned R is like Dr. Petrie learned R. R came out in 1993. Yeah, there you go, Mohammed right there. And if you've got, imagine if you walked out of UT and you're like, I know how to use Python, I know how to use R, I know how to use Tableau, I know how to use SQL. Companies would be like, yeah. What you wanna interview with us, please? We'll do that. So our goal is to give you as much of a skill set as possible. Python is great, R is great. I just lean towards R. So in another alternate universe, there's an alternate Brian. I bet we could find that alternate Brian who's teaching with Python. Let's go find him. Where'd my screen change? Where's alternate Brian? There he is right there. In the alternate universe, Brian is teaching. It's that Brian over there. You have to figure out which one's the real Brian, though. You don't know. It's like, I'm the real Brian. No, I am the real Brian. Okay, this bit's over. We're going back. Going back to the past. Okay. Let's start talking about the next question right here. Let's do it. And there might be some questions in the Discord, so I'll check that out. Okay. Question number 3. After loading in the R data file, let's see right here, load the alumni. And you like the one on the right? He's probably the real Brian. He's around more often. You'll be using the data frame for the questions. Remind yourself of the R command that determines the type of an object. Cool, right here. So the type of an object, there's 2 ways to do this. There's type of, and then there's class. There's type of and class, and they really do the same thing. So you don't need to know both. I think we should Google, like, what is the difference between type of and class? I don't use type of, I use class. I think type of gets a more specific way of viewing it, just so you can see, like, we'll pull up the alumni data set here, which we currently have loaded in. Make sure you've got the alumni data set loaded in. Yep, if you load it in the R data file. If you don't have it loaded in, please contact me immediately, because if you click this button, it should run all code above. And if it's not loaded in, it's probably because you don't have your working directory set properly. So if you don't have alumni loaded in at this point, you should see it 1 in the upper corner over here, alumni. That means the data set's loaded in. If you don't see that, it's probably because your working directory is not set, especially if you hit this load all chunks above. This loads all chunks above. You can see it running all chunks above. This runs the current chunk, which is the large data set that I ran. And then this is chunk options, how this chunk is kind of going to run. So we don't really need to see that right there. Like, I can call it a different name. 3B, awesome, cool, new name. You can go around between the names of chunks with this right here. So you can hop around your document. Like if you were like, wait, Brian, I'm not on that question. Where is it? It's 3B, awesome. There we go, we're back on it. So that's the whole point of this right here. It's just tabs for you to go across the different sections of the document. Pretty good and pretty easy to use right there. So class tells us how R sees an object. You can use type of, and I wanted to show the small difference right here. $ connects data frames to variables. The $ connects the data frame to a variable. I can't say that enough. So let's go here to lifetime gift to UT. Lifetime gift to UT. So lifetime gift to UT is a numeric vector. I prefer to use class. And so it's going to say numeric, which means it's quantitative. But if you do type of, it's going to tell us double, which is double decimal precision. And Mohammed, if you know any C++, you probably know about how like things are stored in memory. So this double decimal precision right here is like just telling us, I think it's stored at, oh, someone correct me if I'm wrong. I think it's stored at 32-bit memory allocation. And I wonder what's going to happen if I do this. Do not do this randomness I'm doing right here. integer. I'm going to turn it into an integer and run type of. Now it's an integer. So integers take up less memory allocation. Double decimal precision take up more memory allocation. And I am literally just doing random things. But this question right here is just wanting you to do this, and that's an integer. So it takes up less memory allocation. We usually use like numeric, at least in our coding world, we're not so worried about how much memory something is taking up. We just use it as it is. And I guess if we're doing neural nets or something, we might start to be like, let's try to make sure we take up little bits of memory, because if we have the memory, we'll have the time. So it depends. There's always instances, but especially in like 201, 320, memory is not an issue. Memory and processor, we're pretty good. We got good computers these days. So this is how we take the class of an object, and we can just take the class of these objects up above. What do you think alumni is? It's up here in the top corner. Mohammed, what do you think alumni is? Let's put another one here. Oh, we had to do lifetime gift to UT. We have to do most of these. So I think this one's kind of obvious. I might not do the rest of this right here, but these will tell you what this is. And what is it? It is a data frame. I need like I don't know, like what is it from, like, I think there's a group of things that. But this one here is going to be the vector inside of it, just so you can see alumni lifetime gift to UT. If you look inside the alumni data frame, you can see the lifetime gift to UT vector, and it's just like an Excel spreadsheet. Where are you, lifetime gift to UT vector? It went away. It's gone. It's not here anymore. What you can do is you can do this. Watch this. Here's code we don't need to do right now, but it doesn't hurt to know things. We can go here to call names and call names alumni. And there's all the column names, and there's the log of it. Let's go to this and say equals lifetime gift to UT, and then let's say which. The answer is, it is the 58th column. Now I gotta like look through here and find the 58th column. There's 79 columns, so 58 is gonna be right about here. Where are you? We must have just passed it. Am I going? Oh, you know what? It always does this. There's only 50 columns on display. Oh, that's why. It's going to be towards the middle now. There it is. I'm not going mad. I think Jumpstart R started doing that recently. I don't remember that at the start when I first started doing. Oh, and you can search through this? What? You could be like, oh, let's only see 55 through 60. So I didn't even realize this. They have. I don't want 55 through 104. That's 55, 56, 57, 58. And was it 58? Yep, column 58 right there. So we could start it at 58, and it'll just advance that to a random number. So that's probably a good way right there. I'm always learning new things. I don't usually view my data like this. You could pull up the vector, because I think when you start out, you might view things more often. But then as you start coding more, you're like, okay, if I want to view that vector, I might just do the following to view it. I might just highlight the code and run it. And then I can see the values inside of there. So then there's all the values down here at the bottom just being displayed. And so that's the vector. So does that help with that question right there, Mohammed? We should be good on that one, I think. A lot of great work done on these questions today. So let me see. I'm going to look at the Discord. So class is the function we use to display what R sees. Boom, Evan right there, 100 points. Asking question at office hours. Great job. Class is how R sees it and how it manipulates it. So if you have something like... this right here, which is going to be a numeric vector. And then if you have something like the gender code, which is a factor, I believe, you can see R manipulate. And be very careful. Don't include things like this. Let's ask MuBot what it thinks. Once again, I can't repeat this enough. Oh, that's wrong. MuBot, tell us about when Brian's coding. MuBot will inform us. So don't write everything I write. MuBot knows about that. If you go here to table of this, let's do summary. Summary acts different. If you do a summary of this versus a summary of this right here, you get the 5-number summary plus the mean for quantitative, because this is a numeric thing. So R uses the 5-number summary plus the mean, but this one is a factor. Remember that this is a factor right there. So R is going to give us a table of this. So R gives us a table of gender code. So gender code gets a table because it's a factor, But since this one is numeric, i.e. quantitative, it gets the 5-number summary. So both of these are using the summary option, but R sees these differently. So R sees this as numeric, quantitative for all intents and purposes. R sees this as factor, which is categorical. And because of that, 5-number summary plus mean, and yep, that's left and good T, and frequency table. And a good review for Stat 201 if Stat 201's watching. I like to mention how this relates to Stat 201 is frequency tables are univariate displays of categorical data, and we could do a histogram right there. Boop. Histogram is a univariate display of quantitative data. So I could make a histogram of lifetime gift UT. Why not do that? Frequency table. One of the things I like about this so much is you could just call this X, and then you can manipulate it really quickly because you can just do a histogram of X, a box plot of X. You can do, you know, the mean of X. So we can do very quick manipulations on this. We can find hint for later on, the sum of X for everything that people gave, the total amount of gifts given, $250 million. Pretty awesome right there. I wonder if there's a way to make art. There's probably a package that would say like $255,819,127. So like, I could write something. It wouldn't be a good utilization of office hours time, but I could have it chunk out and have it do up to a certain amount. And then maybe after like $1 trillion, it just says more money than anyone should ever have or something. I mean, if you got $1 trillion, I mean, if you got $1 trillion, that's a lot. I'm not saying no one should have that, but I mean, just like, I mean, at what point? What if it's like what comes after $1 trillion? There's a million, a billion, a trillion, and I think there's a quadrillion and quintillion, because you're going mil, bill, trill, qua, quint, sex, cent, oct, nina. I don't know the 9, and then deca, I think. It's weird. I don't know those. It's like Greek stuff when it gets up to like there's like after, you know, giga, tera, and then there's like iota, zeta. There's the bigs and smalls, and they're very small. I don't know any of the small for the Greek because we don't use that kind of stuff for what we do. We use like gigabytes and terabytes, so and petaflops and all that stuff right there. So that's come after giga. So I don't, you know, it's good random stuff. You know, it's the craziest thing. This is Brian's quick aside right here. What is it? If you look into like calculus, when you do derivatives, those things get crazy with like snap, crackle, pop. Like there's these weird names for like the 4th, 5th, 6th, 7th, 8th derivative. And I don't know who's making them up, and I don't know why they made them up. But if you look into calculus with like the 5th derivative, the 6th derivative, it gets into these weird like snap, crackle, pop, like Rice Krispie treats. I'm like, did someone who was just like eating their breakfast cereal was like, okay, I'm calling these. You know what I should call? I should name the 15th derivative. I don't think there's a name for that yet. And we'll do some. If you have more questions, feel free to ask them. I'm going to look at Discord here in a second. The 15th derivative is now a Thanos. It's a Thanos. It's another snap. It's a variation on snap. The 15th derivative is a Thanos. You need to know that right here. Mubot's gonna learn that, and we're gonna look into the see if there's questions. So let's put to quotes. Mubot's gonna know this now. It's an inside joke that only I get. Did you know the 15th derivative is called Thanos? Probably misspelled derivative. Okay. Mubot now knows that. You don't know that though. Let's take a look, see if there's other questions. Oh wait, here we go. Awesome. Jessica's doing office hours right now. And cool stuff. People have joined. We got questions. Let me see. Someone saying thank you. Thank you. Let me say good job right there. And I'll see if there's more questions in the chat. So if you have questions, feel free to ask. If you have questions, feel free to ask. Good office hours today. Got a lot done. So everything's going over here. Had some great office hours. I think we did it right there. Cool. I think we've done it. Awesome. Can you work number 5? Yeah. Let's take a look. It is 320, right, Evan? It's 320, right, Evan? I'll start getting serious right here. Let's work parts of number 5. I did number 4 in the other video, so there's a lot of help here. There's a lot of help. We got 15 minutes. I might take a small break and even do a little more after that. Okay, how many levels does Greek have? I need your help right here. I need your help on this. So if you want to look at how many levels something has, you need to then first look at it. So what I'm going to do, and you don't have to do this. I need to, like, Brian is doing this. You can link the video if you want. Already covered it. Oh, no, we haven't covered this one yet, I don't think. I don't think we did this one yet. I'm not gonna put my responses down here yet. I'm gonna go and delete this, and I'm gonna put my responses in line with it. Does that make? I don't have to do this, and I can call this right here a chunk name of 5A. It helps us just kind of understand what's going on here organization-wise. You don't have to do this. I'm just doing it so I can see the question and then write it, and it helps me kind of understand, if I'm new to this, how to, like, make my own documents and put in chunks and, you know where to code. So this is where I code. This is where it's just a Word document. This is Word document, and this is code. So if you type Word document here, it's going to get angry. So try to run it, and it says, I don't know what that is. There, it's angry now. Good. I said it would get angry. Now it's a comment. So this is a code document. So this is the coding area in a chunk, and then this is the Word document portion in the white area that we see up there. So small but subtle differences. We have how many levels does Greek have? So Greek, did we create a new variable Greek, or is it in the alumni? And I think we created Greek, right? Did we create Greek previously? I think that's what we do previously. Uh-oh. Add a column called, that's where we add it. I knew we were doing something here. Add a column called Greek that is initially a copy of this. So we need to initially do that. We can do that right here. This is almost like prep work. So I'm going to add a chunk right here and call this before 5. So that's the before question for 5. So here's something you may not know. If you go to the alumni data set and hit $, you get the variables inside of it. Boom. There's the variables inside of it. What do I mean by variables inside of it? Well, like an Excel spreadsheet. Here's the Excel spreadsheet. And here's the variables inside of it: gender code, zip code, area code, email address, job title, all that good stuff right there we have. And here are the variables for easy use right there. Now, what we need to do is we need to first look at fraternity sorority. Boom. Here's fraternity sorority, and there's the fraternities or sororities people are a part of. But we want to add a column. To add a column to a data frame that does not exist, you simply do the following. You go here and don't do this example. You just add in what you want to add. Like, I want a column to be called Brian, and it to contain all 5s. If I go down to the bottom of this data set right here, what do we see at the very end? A column of all 5s that is Brian. And just to view it again to make sure we know what we're seeing, this is literally a new column at the end of this data frame. I added this on. So look at the code I ran right here. I stored into the column Brian that does not exist, and I stored the number 5, which just repeated the number 5 the whole time. So it says make a copy of the Greek, and we might be able to view this at the same time while doing it. It says make a copy of this and store it into something that does not exist. If you notice, as I type this, it doesn't appear. That's because it does not exist. But I'm going to, as you can see right next to me right here, store that thing that does exist, fraternity sorority, into this, and I think it'll update, and we'll hit the end button right here. And we'll go to the end, and there it is right there. Now there it is. I was going to say, you might say, it's not there, but it is. There's just not information for those individuals. They are, I think they're blank. I think they might actually be this kind of blank right here. We'll take a look in a moment here and see what kind of blank they are throughout these questions. How many levels does Greek have? Well, now that we have Greek, you know what I'm going to do? You're gonna have to, like, see. You're gonna have to be paying attention. Evan, are you good? How you doing, Evan? You're the one who's here, so you kind of get to direct the office hours. Are you good? Do you think you maybe know how to get that pre-work done? Even though I've got that up there, Mubot will tell you. Mubot says one of Mubot's favorite quotes right here. So do not write everything Brian does when doing an assignment. Do what Brian says, not what Brian does. Brian is usually right, but sometimes too right. We made that up this morning. So does this make sense, Evan? How are you doing? And I'll do the next part here. Talk about the next part. I think we might be good. We'll double check. So, how many levels does Greek have? When we talk about how many levels does Greek have, well, levels just means like if you went to a pizza store, pizza parlor, and they had different. I keep thinking about pizza. We have pizza, and we made hamburger helper last night, and I just keep thinking pizza. I just want pizza. Now it's gonna be Friday. Yep, that's basically it. Just make sure it's all spelled out. Great job. You can leave that in the chat too. That's Greek should technically be capitalized, but tomato, tomato, it's no big deal. So if you went to a pizza store, parlor, and they had different types of pizza, that would be the levels. And then you say, okay, how many pepperonis do you sell? How many extra cheese do you sell? And so each one of those is like a level. Like if you go to McDonald's, use McDonald's, they have different menu items, so it'd be different levels of things they have on their menu. And what do we mean by levels? It's possible possible answers to a categorical question. Levels are possible answers to a categorical question. So just think of any categorical question like, what state were you born in? Well, that has, I guess, 51 levels. We include Puerto Rico. So I guess that's the territory, is it? I don't know. Or maybe it's 50, like a state or other, or like does not apply, or blank. We leave NA, which is kind of not really a level. It's just missing data. So it's like the levels would be all the different answers people could give. So just depending on how we phrase the question, there can be different levels. So the function for it is just levels, but be careful here because we need to go a little further on this. We're going to pull up the Greek vector, make sure you did the pre-work, not the Brian. That's not the answer. The answer, yeah. This is going to show us all the different levels, and the answer is right there. Now, you can technically, just to show, the answer's on the screen right here. These are all the different levels, and if we go all the way to the top, I think we see the blank level. This, if you notice, level 1 right here is just a blank quote. So that's the people where we saw nothing. It's not actually an NA for those people. It's a blank quote. It's a quote with nothing in it. So it's not NA. These people do not have NA in their field. I'll show you. These people right here do not have NA. They actually have that blank quote. To show you down here, that's what they have, and you don't see the quotes because it would be like someone entered a quote. They entered nothing. But you can see a difference right here if you go back to the beginning where this area code is missing. This area code right here is actually NA, and that's not the word NA. That stands for a quantity of missingness. It's like that cell has nothing in it. This cell at the very end has a blank word in it. It has this. This is what the cell has in it, and how can we confirm that? By looking at the levels vector, we can see that someone entered in a word with nothing in it, and that's what it has. So with this right here, how many levels does it have? Well, we're just one step away from figuring out how many levels because we don't want to just look at the levels vector. We want to find out how long it is. And when I say how long it is, you should say length. The length of the levels vector right here is going to tell us how many levels there are. One person wrote this. I'm not going to try to attempt to write that because I will make an error if I write it. What position are they in the levels vector? Now, I think this is where people make a mistake is because I'm entering in my chunks here. So we'll call this 5B. What position is this in the levels vector? I could call this name. We're probably going to see everyone doing this on the assignment now. That's just an easier way to store it so I can kind of see what I'm doing right here. And we're going to go to the levels vector of alumni. And we're going to go to Greek. And we want what position are they? So we could just look through this. Okay. UTK omega psi phi. UTK omega. We're almost there. It's alphabetical. There we go. They're 40. Solved. But imagine this was a million observations, a million levels. And we said, okay, which one is it? You'd be like, okay, I got to scroll through. We can make it much easier. Why don't we ask which one of these levels vectors is equal to this? And we're just asking equal to the name. Now it's going to tell us true or false. And we see this right here. Now, how can we figure out the positions of the trues? This is a big note to take. So which figures out the positions of the trues. So if you put everything we just made inside of a which, it tells you which things meet the conditions. So which gives you the positions of the things that meet the conditions. That's our rhyme. I keep forgetting to say that. Which gives you the positions of the things that meet the conditions. Which gives you the positions of the things that meet the conditions. So what do we mean by meet conditions, true or falses? And what do we mean by positions, where they're at in the vector? Remember, this was at 40. And so here's the level we were looking for. And then down here, we can see the trues and falses. That's why we got a true right here, because that is, we checked. We said, okay, you know, where is that? It's here. We checked what levels are equal to that name. It was this level. And then which tells us the position. This is in position 40. That true right there is at position 40. If you went 34, 35, 36, 37, 38, 39, 40, because that's the starting position of this one right here. How many people went Greek in this data set? There is only one level that's not Greek. I need someone to say it in the chat. I need to see it in the chat. What is that one level that did not go Greek? What is the one level that did not go Greek? Can anyone remember the one level that did not go Greek? What is how was it spelled again? We have some hints all throughout here. How do we spell that one level that did not go Greek? Like, what is the way it was like given? Given some hints, because all of these are Greek. It's like all these are Alpha, Chi, Farmhouse, all these things right here. So all of these are levels that went Greek. Let's enter in a chunk so we can do code, because I'm going to code right here. 5C. And so the one level that did not go Greek was that quote, quote. And you can see, once again, we can see where that is in the data. And it's over all the way here. It's hard to tell this, but what's in these cells right here that we don't really see anything in is this. That's what's in those cells. I know it doesn't look like it. You're like, well, I don't see quotes. Well, it's because it's a word with nothing in it, and it doesn't put the quotes. Quotes are strings, so it shows like this. It looks like it's NA, but it's not NA. That's the trick, Evan. Another 100 points. Thank you for being here, Evan. You would think this is NA, but it's actually a word with nothing in it. So it's not a nothing, nothing. It's a word with nothing in it. Over here, this is NA, and that's how it'll tell you there's an NA. So you see how right here we can see there this cell has missingness in it. So this cell right here has missingness in it. This cell right here, although it might be hard to tell, has a word with nothing in it. Now I'm going to make this even more confusing, because here's the thing. You see how this looks like nothing right here? Watch this. I'm going to go to column 80. Let me do this. This is not something you should do. Do not do this. Do not do this. I'm going to go to alumni. I'm going to go to Greek. And I'm going to go to the first element. I'm going to overwrite it with that. Oh, did I not like that? What did I do? Warning message. I generated an NA. I think why that generated an NA. What's in there now? It made it an NA. That's cool. So now actually, if we go look at it, did it generate NAs and things that don't exist? Oh, keep forgetting we got to do that. There's an NA. There's an NA right there. Had an unintended consequence. There's an NA right there. Oh, that issue. The reason it didn't work is because this is fun. We have to go to the levels vector of alumni $Greek. Dr. Pichu would be like, why did it not work, Brian? I'd be like, because, and he'd be like, yep. So we have to go to the levels vector and depend onto it. No, this is super confusing, Andrew. Great job, Andrew. 100 points, Andrew. Used to get points. You have to append onto the levels vector this new level. So I have to update the levels vector of alumni Greek because I tried to create a level that did not exist, because you can only create levels that exist. And so now I can store that. When I tried to store before, there was no level space nothingness, or nothingness with a space. So now in if we go to the alumni data frame, because even caught me off guard, that was a genuine mistake. Mubot, where you at, Mubot? Mubot, you guys can always, oh, not in the right spot. What? What's going on here? That was weird. There we go. So Mubot will count my errors for me. Mubot, you're mean. You should try some of our new quotes, Andrew. Try some of our new quotes right there. It's a good one right there. Oh, you already saw that one, I think. So in this one right here is NA, which is nothingness. And in this one right here is a space. Oh, you can highlight it? Look, you can even confirm. That space I just made right here is this. But this one has inside of it this. So here's what's in space 2. In space 2 is that space. And in this one right here is this. In this area, because I can't highlight it. I could show you that by going to position 3 and putting in like a bunch of spaces. But I have to update the levels vector. All right, 2 seconds. Because I can't store that unless the levels vector has that. So now the levels vector has that. And now I'm going to go to space 3 and put in that crazy space thing right there. And then I'm going to go take a look at alumni. And we're here. And there's the 1 space and 2. And then there's the big space I put in right there. So it's hard to tell that nothing is there. Does this all kind of make sense? This was a big thing to just basically say, and I need to maybe reload alumni after this because I broke it. I'm going to reload alumni. Alumni's fixed. Don't do this craziness. The whole point of this right here, and I've ran everything above, so we should be good. The whole point of this right here, and please run your code. Hopefully you didn't run that code I ran, is we're going to go to Greek. Did I create the Greek data frame? What? Oh, I left out that code. Okay, well, I have to actually write that code now. What was that code that I was like, you need to do this on your own? Well, too bad. Now we have to do it. Now we have to go here and do the code. Greek does not exist. And then alumni. There we go. That's why that did not exist. Now it exists. And so here we're going to look at the people, how many people went Greek? So we want the people who did not go Greek. So this is where it gets confusing, and I'll do the last one here after this, and we'll end the office hours. But great office hours today. Good questions. We got through a lot of the problems, so hopefully this video really helps. But we want the people who did not go Greek. Do you hear the double negative? We want the people who did not go Greek. We want the people who did not go Greek. And so let's go right here. So we want alumni, $Greek, and then we want people here. And these are the people who, whether or not they did not go Greek. So let's see here. Yes. So these are the people who did not go Greek. So what we can do is we can take all of this and we can flip it. And these are the people who went Greek. So what's the exclamation mark do? It flips trues and falses. So anything that was true is now false. Anything that's false is now true. And these are the people who did go Greek. And these are the amount of them. Hopefully that's right. Please email me if I'm wrong. But these are the people who, sorry about the cough there. These are the amount of people who did go Greek. So with this right here. Oh, awesome. And then what integrity issues do you see with the levels vector? What integrity issues do you see? I'm going to let people figure this one out right here. Let's go and look at it. And I want you to think about this. I want you to think over things like this. I want you to think like, what's odd about this? What is odd about this? What is odd about These are people who donated and what Greek life they went to. So put your thoughts in. I think that's got it. Anyone still here? Anyone still here to say hey, to say goodbye? We'll head off. I'll see people later in class. But great stuff. Andrew, so good seeing you, man. Swing by anytime. Love having you here. Hope you're doing well. Don't cut the hair. I'm going to cut my hair. It's going to be a sad day. But that's got it. I'll talk to everybody later. It's bye for now. Bye.